Hello, in this lecture we will find out the radius of a circle using two different methods. In the drawing we have a circle inside and we know that the center of the circle is at point O here, and line segment AB equals to 6 units, line segment AD equals to 18 units, line segment BC equals to 13 units. This angle BAD equals to 90 degrees. Angle ABC, this angle equals to 90 degrees, and our mission is to find out the radius of this circle. Okay, so first of all we'll do a construction. That is to say, from point C we draw perpendicular on AD. So this angle equals to 90 degrees and this angle equals to 90 degrees according to our construction. We will define the touching point of the perpendicular from point C and AD as E. By doing this construction, we actually created quadrilateral ABCE, this quadrilateral, and inside this quadrilateral we have 1, 2, 3 right angles. Therefore, the fourth angle, this fourth angle, must be also equal to 90 degrees, according to the rule that the sum of the angles in any quadrilateral is equal to 360 degrees. So 270 degrees, that is the sum of the three right angles plus the missing angle. In total, it must be equal to 360 degrees. Therefore, the missing angle must be equal to 90 degrees in order to complete the sum of the angles in this quadrilateral to 360 degrees. This angle BCE, must be equal to 90 degrees. So actually, quadrilateral ABEC has four right angles, and therefore quadrilateral ABEC is a rectangle. And we know that the opposite sides of a rectangle are equal to each other, that is to say AB equals to EC. But AB equals to 6 units, therefore EC also will be equal to 6 units. Likewise, according to the same rule that the opposite sides of a rectangle are equal to each other, we get that BC equals to AE. In rectangle ABCE, BC equals to AE, but we know that BC equals to 13 units. It is given us the question, therefore AE will be also equal to 13 units. Okay, and what is the length of line segment ED? The length of this line segment ED, it will be equal to AD minus AE. Again, AD minus AE equals to ED. That is to say, ED equals to AD, that is 18 units, minus AE, that is 13 units. 18 minus 13 is 5. So ED equals to 5 units in its length. In the next step, we will join points D and C together by a straight line. Actually, by joining points D and C, we created here the right triangle ECD. This right small green triangle EDC. So we implement the Pythagoras theorem on this right small green triangle. Triangle ECD. Here by PT is a relation for Pythagoras theorem. According to the Pythagoras theorem, in any right triangle, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. The hypotenuse in the green right triangle is DC, therefore the square of the hypotenuse is DC squared. And it must be equal to the sum of the squares of the perpendiculars, that is to say, it must be equal to EC squared plus ED squared. I repeat again. In the right green triangle ECD, according to the Pythagoras theorem, DC square equals to EC square plus ED square. So DC square, that is the square of the hypotenuse, must be equal to, according to the Pythagoras theorem, EC square. EC equals to 6 units, as you can see here. Therefore, EC square equals to 6 squared, that is 36, plus ED square. ED equals to 5 units. Therefore, ED square equals to 5 squared, that is 25. So in conclusion, we found out that DC square equals to 36 plus 25. That is to say, DC square, that is the square of the hypotenuse, equals to 36 plus 25 is 61. So DC square equals to 61. We'll take a root out of this equation and we'll get that DC, that is the hypotenuse, the length of the hypotenuse, it is equal to the square root of 61. Okay, DC equals to the square root of 61. We can write here that the hypotenuse DC equals to the square root of 61 units. Okay. In the next step, we join points B and D together by a straight line. By joining points B and D, we actually created here the right triangle ABD. Okay, so we'll implement the Pythagoras theorem on this right triangle ABD. Again, by PT is the formation for Pythagoras theorem. According to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. The hypotenuse in the right triangle ABD is BD, therefore the square of the hypotenuse is BD square, and it must be equal to the sum of the squares of the perpendiculars. That is to say, it must be equal to AB square plus AD square. I repeat again. In the right triangle ABD, the right big triangle ABD, according to the Pythagoras theorem, BD square equals to AB square plus AD square. So BD square equals to AB square. AB equals to 6 units, therefore AB square is 6 squared, that is 36. Plus AD square. AD equals to 13 units, according to what is given us the question. Therefore, AD square, AD actually here it is 18. Again, AD equals to 18 units, according to what is given us in the question. Therefore, AD square is 18 squared, it is 324. So in conclusion, we found out that according to the Pythagoras theorem, in the right triangle ABD, BD square equals to 36 plus 324. That is to say, BD square equals to 36 plus 324 is 360. So BD square equals to 360. Here we'll substitute 360 by 36 times 10. So we'll get that BD square equals to 36 times 10. Here we'll take a root out of this equation and we'll get that BD equals to the square root of 36 times 10. Here we'll take 36 out of the root. So BD will be equal to the square root of 36, that is 6, times inside the root we'll have to only with 10. So we found out that the length of the hypotenuse BD is equal to 6 times square root of 10 units. Here we can write down that the length of the hypotenuse BD is equal to 6 times square root of 10 units. Okay, so in the next step we'll find out the area of instead of triangle BDC, this triangle. Repeat again, we'll find out the area of the green triangle, triangle BDC. The area of triangle BDC here, the square bracket is the sign for the area. It means the area of triangle BDC is equal to the base of the triangle times the height to the base over 2. Here I must emphasize that the height to the base must create 90 degrees with the base. Okay? So the area of triangle ABC equals to the base of the triangle, so we'll choose the base as BC. Side BC is the base. Here this side BC is the base. Times the height over 2. The height to the base must create 90 degrees with the base. So this is the area of triangle BDC equals to BC times the height over 2. Here we will extend side BC, a straight line, and from point D we will draw perpendicular of the extended BC. So this angle equals to 90 degrees, and this angle equals to 90 degrees according to our construction. We will define the touching point of the extended side BC and the perpendicular from point D as F. So actually DF is the height to the base BC. Why? Because of the fact that DF creates 90 degrees with the extended BC. So DF is the height. In the next step we'll find out the value of the height DF, the height to the base BC. So actually here by this construction we created quadrilateral ABDF. This quadrilateral, in quadrilateral ABDF we have 1, 2, 3 right angles. Therefore the fourth angle, this fourth angle must be also equal to 90 degrees. So in quadrilateral ABDF we have 4 right angles, and any quadrilateral that has 4 right angles must be at least a rectangle or flat a square. So we will relate to quadrilateral ABDF as a rectangle. I will write it down. Quadrilateral ABDF is a rectangle. Why? Because it has 4 right angles. But we also know that the opposite sides of a rectangle are equal to each other. That is to say, in rectangle ABFD, AB equals to DF. AB equals to DF, and it is given us the equation that AB equals to 6. Here AB equals to 6, and from this equation 6 equals to AB equals to DF. We will derive that DF is also equals to 6 units. Here DF equals to 6 units. That is to say the height of the green triangle is equal to 6 units. Now we can find out the area of the green triangle. So according to the formula that the area of triangle ABC here it is equal to the base BC, and it is given us the question that the base BC, it is equal to 13 units in its length, so we substitute the base BC by 13 times the height. We just right now found out that the height is equal to 6 units. You can see that the height to the base creates 90 degrees with the extended base BC. This angle equals 90 degrees and this angle equals to 90 degrees. So the height equals to 6 units, all divided by 2. Here 6 over 2 is 3, and 3 times 13 is 39. So in conclusion, we found out that the area of triangle BDF is equal to 39 square units. In the next step, I will present to you a new rule, and we will implement the new rule in our drawing. According to the new rule, that will be actually rule number 2, rule number 1. Here, rule number 1, only to rule number 1, if you have a circle, that could be any circle. So, the circle that I will draw could be any circle. The center of the circle is at this point, point O. This is the center of the circle, and inside this circle we have triangle ABC that is blocked by this circle. This is triangle ABC. That is blocked by this circle. What is the meaning of a triangle that is blocked by a circle? The meaning of it is that all the 3 vertices of the triangle that is blocked by a circle are touching the circle. Exactly as you can see in this drawing. This vertex of the triangle ABC touches the circle at point A. This vertex of the triangle touches the circle at point B, and finally this vertex of the triangle ABC touches the circle at point C. Only and only if all 3 vertices touches the circle at 3 points, we can say that the triangle is blocked by a circle. Exactly like in this drawing. So according to rule number 1, if a triangle is blocked by a circle, or we can also say if a circle blocks a triangle, it is the same thing. Then the radius of this circle that blocks the triangle, here, point O is the center of the circle, point M is the point on the circle itself, therefore OM is the radius of the circle that we will define as capital R. So the radius of this circle is equal to capital R, is defined as capital R according to our definition. So the value of the radius, of the length of the radius, capital R, whenever you have a circle that blocks a triangle, like in this drawing, the length of the radius of this circle that blocks triangle ABC will be equal to, here, actually the length of side AB equals to A units, the side AC equals to B units in its length, and side BC equals to C units in its length. So the value of the length of the radius of this circle, or M, that blocks this triangle ABC, will be equal to the multiplication of the side lengths of the triangle by each other, that is to say A times B times C over 4 times the area of triangle ABC that is blocked by the circle. This is the sum for the area. Again, if we have a circle that blocks a triangle, like in this drawing, then the radius of this circle that blocks triangle ABC will be equal to A times B times C, that is the multiplication of the side lengths of the triangle by each other, over 4 times the area of this triangle ABC that is blocked by the circle. So we actually can implement this new rule number 1 in our drawing. Why? Because in our drawing we have a triangle, the green triangle DBC. First of all, the green triangle DBC is blocked by this circle. Why? Because all of its 3 vertices are touching the circle. This vertex of the triangle DBC touches the circle at point B. This vertex of the triangle, of the green triangle, touches the circle at point C, and finally this vertex of the triangle touches the circle at point C. Therefore, indeed we can say that the green triangle is blocked by the circle, and therefore we can implement here rule number 1. So I write it down. As I already showed you, the green triangle BDC is blocked by the circle, and therefore we can implement here rule number 1, and according to rule number 1 we get that the radius of the circle that blocks triangle BDC, here we will define the radius of this circle as capital R. Point O is the center of the circle, here point M is the point of the circle itself, therefore OM is the radius of the circle that we will define as capital R. And according to rule number 1, the value of capital R, the length of the radius capital R, will be equal to the multiplication of the side lengths of the green triangle by each other. The length of this side is BC, times the length of this side of the green triangle is DC, times the length of this side is actually BD. So the radius of the circle that blocks the green triangle BDC will be equal to the multiplication of the side lengths by each other, that is to say BC times DC times BD, over 4 times the area of the green triangle, triangle BDC. Exactly according to rule number 1. Okay. So the radius of the circle that blocks triangle, the green triangle BDC, will be equal to BC. BC equals to 13 units according to what is given us the question. And we have already found out that side DC of the green triangle BDC equals to the square root of 61 units. And finally, side BD, we have already found out that side BD of the green triangle BDC equals to 6 times square root of 10 units. So actually, those are the lengths of the three sides of the green triangle, all divided by 4 times the area of triangle BDC. And we've already found out that the area of this green triangle BDC equals to 39 square units. So actually, that is the answer to the question. The radius that we are looking for, that is to say, the radius of this circle is equal to this expression. Now we will simplify this expression by dividing this expression, both the numerator and the denominator of this expression, by 13. So the radius of the circle that blocks the green triangle BDC will be equal to 13 over 13 is 1, so 13 will get cancelled. And we left only with square root of 61 times square root of 10 times 6. In the denominator we have 4 times 39. And we have to divide the denominator also by 13. 39 over 13 is 3. Okay. So the radius of the circle that blocks the green triangle BDC, here in the denominator we have 4 times 3 is 12. In the numerator we have square root of 61 times square root of 10 times 6. Here we divide both the numerator and the denominator by 6, and we will get that the radius of the circle that blocks the green triangle BDC equals to the square root of 61 times square root of 10, and 6 over 6 is 1, so 6 will get cancelled. And we left only with in the numerator with square root of 61 here, times square root of 10, all divided by 12, so we have to divide the denominator by 6. That is to say 12 over 6 is 2. Okay. And we have the algebraic identity that states that the square root of A times square root of B equals to the square root of A times B. We use this algebraic identity in order to find out the value of the square root of 61 times square root of 10. It is equal to the square root of 61 times 10 over 2. So I actually found out that the radius of the circle, of this circle that we are looking for, that is to say OM, the length of OM, that is equal to capital R, it is equal to either the square root of 61 times 10 is 610 over 2 units, or in terms of numbers it is equal to 12.349 units. Okay. So we finished with the first method. In the next step we will present to you the second method, how we can find out the radius of this circle. According to the second method, in the second method, we do all the things that we have already done in the first method, that is to say from point C we draw perpendicular on AD. So this angle equals to 90 degrees. and this angle equals to 90 degrees according to our construction. We define the touching point of the perpendicular from point C and AD as E. We actually created a quadrilateral ABCE. This is 4 right angles, and therefore the fourth angle must be also equal to 90 degrees. Therefore quadrilateral ABCE that has 4 right angles is a rectangle, and we know that the opposite sides of a rectangle are equal to each other. That is to say AB equals to EC, but AB equals to 6, therefore EC equals also to 6. Likewise, according to the same rule that the opposite sides of a rectangle are equal to each other, we'll get that BC equals to AE. But BC equals to 13, therefore EA will be also equal to 13 units. We did all those steps in the first method, and we have only found out that ED equals to 5 units because it is actually AD minus AE, that is 18 minus 3 is 5. So until now we did all the things that we have done here in the first method, and from here we will continue with the second method. That is to say, from the center of this circle, that is actually at this point, point O, we will draw perpendicular on chord BC. So actually, this angle equals to 90 degrees, and this angle is also equal to 90 degrees according to our construction. We will define the touching point of the perpendicular from the center O to BC, or as point as N, or capital N, and we define the touching point of the perpendicular from point O and AE as M. In the next step, I will present to you a new rule, and we will implement the new rule in our drawing. This will be rule number 1, or rule number 2. Rule number 2. Rule number 2 is true in any circle, so the circle that I will draw could be any circle. The center of the circle is at this point. We define the center of the circle as point O. Here we'll draw chord BC, that could be any chord. This is chord BC. And from the center of this circle, that is to say from point O, we will draw perpendicular on BC. That is to say, this angle equals to 90 degrees, and this angle will be also equal to 90 degrees according to our construction. We will define the touching point of the perpendicular from the center of this circle, that is to say from point O and BC as M. So, according to rule number 1, the perpendicular from the center of the circle, in this case the center of the center of the circle is at point O. Again, the perpendicular from the center of the circle to any chord. Here actually chord BC could be any chord. Bisect the chord. Bisect the chord. That is to say, according to this rule number 2, if the perpendicular OM bisects chord BC, it means that BM equals to MC. BM equals to MC. Okay? So, whenever you draw a perpendicular from the center of the circle to any chord, that perpendicular will bisect the chord. In this case, perpendicular OM bisects chord BC, and therefore BM equals to MC. So actually, we can implement rule number 2 in our drawing. Why? Because in our drawing we have the perpendicular ON on BC, on chord BC. Whenever you have a perpendicular from the center of the circle towards any chord, in this case it is chord BC, then the perpendicular ON bisects the chord. That is to say, BN equals to NC. Okay? So I write it down. In our original drawing, the perpendicular ON from the center of the circle that is to say point O bisect the perpendicular ON from the center of the circle to chord BC, bisect the chord. That is, of course, according to rule number 2. Seventh dimension, whenever you have perpendicular towards any chord, it will bisect the chord. That is to say, the perpendicular ON bisects chord BC. It means that BN equals to NC. BN equals to NC. Only to rule number 2. Okay. So in the next step, we'll focus on this quadrilateral ABMN. Inside this quadrilateral, we have 1, 2, 3 right angles. Therefore, the fourth angle must be also equal to 90 degrees. So actually, in quadrilateral ABMN, we have 4 right angles. Therefore, quadrilateral ABMN is a rectangle. I'll write it down. Quadrilateral ABMN is a rectangle because it has 4 right angles. But we also know that the opposite sides of a rectangle are equal to each other. That is to say, AM equals to BN. AM equals to BN. Likewise, we'll focus on the lower quadrilateral MNEC. In quadrilateral MNEC, inside this quadrilateral, we have 1, 2, 3 right angles. Okay? Therefore, the fourth angle must be also equal to 90 degrees. This angle must be also equal to 90 degrees. So actually in quadrilateral MNEC we have 4 right angles, therefore quadrilateral MNEC is a rectangle. But we also know that the opposite sides of a rectangle are equal to each other. That is to say, ME equals to NC. ME equals to NC. ME equals to NC, so we can summarize what we did until now. We found out that according to rule number 2, BN equals to NC. But we also found out that BN, it is also equal, that BN it is equal to AM also. So you can write here that BN equals to AM. And we also found out that NC equals to ME. So we can write here that NC equals to ME. So from this long equation, AM equals to BN equals to NC equals to ME, we will derive that AM equals to ME. AM equals to ME. Okay? AM equals to ME. That is to say, 9/7 of side AM equals to side ME. Okay? In the next step, we will extend line segment AD by a straight line until it touches the circle. We define the touching point of the extended line segment DA and the circle as point F. By extending line segment AD, we created here chord FD. And because of the fact that ON is perpendicular to BC, as you can see here, ON is perpendicular to BC. ON is a perpendicular, it is absolutely a straight line. Any perpendicular must be a straight line. So if you focus on the upper side of the straight line ON as point M, here the sum of the angles must be equal to 180 degrees according to rule number 1, that the sum of the angles on one side of a straight line is equal to 180 degrees. Okay, according to this rule, that the sum of the angles on one side of a straight line is equal to 180 degrees. So which angles we have at the upper side of the straight line ON at point M? We have this angle that is equal to 90 degrees, plus the missing angle, this angle OMF. In total, they must be equal to 180 degrees. Therefore, the missing angle OMF must be equal to 90 degrees. 90 degrees plus 90 degrees is 180 degrees. Therefore, the missing angle must be equal to 90 degrees. Okay, likewise, if you focus on the lower side of the straight line ON at point M, here, according to the same rule number 1, the sum of the angles must be equal to 180 degrees. So which angles we have at the lower side of ON at point M? We have this angle that is equal to 90 degrees, plus this missing angle. In total, they must be equal to 180 degrees. Therefore, the missing angle must be also equal to 90 degrees. So actually found out that OM, this line segment OM is perpendicular to chord FD. Again, OM is perpendicular to chord FD. Why? Because this angle equals 90 degrees and this angle equals to 90 degrees. Therefore, we can implement here rule number 2. So I write it down because of the fact that from the center of the circle, that is to say from point M, from point O, the center of the circle is at point O, we have perpendicular OM, or you can write down that OM that exists from the center of the circle is perpendicular to chord FD. Again, OM is perpendicular to chord FD, and OM exists from point O, that is the center of the circle. Therefore, we can implement here rule number 2. According to rule number 2, the perpendicular OM bisects chord FD. That is to say, FM equals to ED. Okay, again, because of the fact that from the center of this circle we have perpendicular OM that bisects perpendicular OM that is, or we have a line segment OM that is perpendicular to chord FD, and line segment OM exists from the center of the circle. Therefore, we can implement here rule number 2. And according to rule number 2, the perpendicular OM bisects chord FD. That is to say, FM equals to MD. Okay, according to rule number 2, FM equals to ED. But what is the value of FM? It is very easy to see that the value of FM equals to FA plus AM. FA plus AM. And it is equal to ED. What is the value? It is equal to, again, FM equals to MD. Perpendicular OM bisects chord FD, it means that FM equals to MD. FM equals to MD. Why? Because chord FD has been bisected by perpendicular OM. It means that FM is equal to MD. So FM equals to FA plus AM. What is the value of MD? The value of MD equals to ME plus AD. MD equals to ME plus AD. So in conclusion, we found out that FA plus AM equals to ME plus AD. Okay? But we have already found out that AM equals to MF. AM equals to MF. Again, MD equals to ME plus ED, and FM equals to FA plus AM. Again, FM equals to FA plus AM. Okay, and we have already found out that AM equals to ME. AM equals to ME, and because of the fact that AM equals to ME, we can cancel them, can subtract it from the equation because they are equal to each other. AM will get cancelled with ME, and we're left only with FA that is equal to ED. We found out that FA equals to ED. Here, line segment FA equals to line segment ED. But we have already found out that ED equals to 5 units. So we can write here that ED equals to 5 units. And from this equation, FA equals to ED equals to 5, we will derive that FA is also equals to 5 units. FA equals to 5 units. You can write here that FA equals to 5 units. In the next step, we'll extend side BA until it touches the circle. We'll define the touching point of the extended side BA and the circle as point P. Here we'll implement the old rule number 2 in our drawing. According to the old rule number 2, if chord AB, this is chord AB intersects with chord CD, this is chord CD at point O, again chord AB intersects with chord CD at point O, then AO times OB equals to CO times OD, again AO times OB equals to CO times OD. We can actually implement the old rule number 2 in our drawing. Why? Because in our drawing we have chord FD, this is chord FD, that intersects with this chord PB at point A. Okay, again, chord FD intersects with chord PB at point A. So we write it down. In our original drawing, chord FD intersects with chord PB at point A. This is the intersection point. Therefore, according to the old rule number 2, we get that FA times AD equals to PA times AB. Again, FA times AD equals to PA times AB. FA times AD equals to PA times AB. FA equals to 5, AD equals to 18, and it is equal to PA, the missing 9 segments, so we leave it as it is, times AB. AB equals to 6 units, so we substitute AB by 6. So in conclusion, we found out that 5 times 18 equals to PA times 6. We will divide this equation by 6, and we will get that PA, the missing 9 segment, equals to 5 times 18 over 6. That is to say, PA equals to 18 over 6 is 3, and 3 times 5 is 15. So we found out that PA equals to 15 units. In the next step, I will present to you a new rule, and we will implement the new rule in our drawing. According to the new rule, it will be actually rule number 4. Rule number 4 is draw in any circle, so the circle that I will draw could be any circle. So here we have chord AB, this is chord AB, that intersects with this chord that is actually called CD, and they intersect with each other at 90 degrees. That is to say, they are perpendicular to each other. The two chords are perpendicular to each other, and we define the intersection point as point O. So I write it down. If chord AB intersects with chord CD at 90 degrees, that is to say they are perpendicular to each other, and the intersection point occurs at point O. Intersect with each other at point O. So whenever we have two chords that are perpendicular to each other, or two chords that intersect with each other at 90 degrees, we can implement rule number 4. Here we define the center of this circle as E. Therefore here EM is the radius of this circle that we define as capital R. So whenever we have two chords that are perpendicular to each other, the following equation will be true. That actually 4 capital R square, R is the radius, or capital R is the radius of this circle, will be equal to AO square. It is AO, so it is AO square plus OB square plus CO square plus OD square. Okay, repeat again. 4R square, R is the radius of the circle, equals to AO square plus OB square plus CO square plus OD square. Okay, we actually can implement rule number 4 in our drawing. Why? Because of the fact that in our drawing we have those two chords that are perpendicular to each other. That is to say, chord FD is perpendicular to chord PB. Why? Because they have 90 degrees between them. They are perpendicular to each other, therefore we can implement it rule number 4. So I write it down. Chord FD is perpendicular to chord PB. Okay? And they intersect with each other at point O. Therefore, we can implement here rule number 4. Again, we will define the radius of this circle as capital R. Here, point O is the center of the circle. Therefore, OM is the radius of this circle that we will define as capital R. Therefore, according to rule number 4, 4 times capital R square, capital R is the radius of the circle. It is equal to FA square plus AD square plus PA square plus AB square. Repeat again, according to rule number 4, of course, because of the fact that chord FD is perpendicular to chord PB, that is to say they create the intersection point between them 90 degrees, here this area equals 90 degrees, therefore we can implement here rule number 4. And according to rule number 4, 4r square. R is the radius of this circle, that is to say OM equals to capital R equals to this is the radius of this circle. 4r square equals to FA square plus AD square plus PA square plus AB square. FA square plus AD square plus PA square plus AB square. So 4r square equals to FA square. FA equals to 5, therefore FA square equals to 5 square, that is 25. Plus AD square. AD equals to 18 units, therefore AD square equals to 18 square, that is 324. Plus PB square. PB equals to 15 units, therefore PB square equals to 15 square, that is 225. Plus AB square. AB equals to 6, therefore AB square equals to 6 square, that is 36. So in conclusion, found out that according to rule number 4, 4r square equals to 25 plus 324 plus 225 plus 36. So 4r square equals to 25 plus 225 is 250, and 36 plus 324 is 360. So 4r square equals to 250 plus 360 is 610. So we found out that 4r square equals to 610. We'll divide this equation by 4, and we'll get that r square equals to 610 over 4. Here we take a root out of this equation, and we'll get that r equals to the square root of 610 over 4. So, or capital R equals to the square root of 610, and the square root of 4 is 2, so we can take out 4, we can take 4 out of this root. So in conclusion, we found that the radius of this circle, the radius that we are looking for, equals to either the square root of 610 over 2 units, or in terms of numbers, it is equal to 12.349 units. That is the answer to the question according to the second method. In the next step, I will summarize the lecture. We'll start with the first method, of course. So in the drawing we have a circle. We know that the center of this circle is at point O here. Line segment AB equals to 6 units, line segment AD equals to 18 units in length, and line segment BC equals to 13 units. This angle BAD equals to 90 degrees, and this angle ABC, it is also equal to 90 degrees. Our mission is to find out the radius of this circle, that is to say the length of line segment OM, that is the radius of the circle. Okay, so in the first step we did a construction, that is to say from this point, that is actually point C, we draw perpendicular on AD. This angle equals 90 degrees, and this angle equals to 90 degrees according to our construction. We define the touching point of the perpendicular from point C and AD as E. By doing this construction, we created the quadrilateral ABCE. This quadrilateral ABCE has 1, 2, 3 right angles. The sum of right angles is 270 degrees, therefore the fourth angle must be equal to 90 degrees according to the rule that the sum of the angles in any quadrilateral is equal to 360 degrees. Okay, so inside quadrilateral ABEC we have 4 right angles, and therefore any quadrilateral that has 4 right angles will relate to it as a rectangle. And you know that the opposite sides of a rectangle are equal to each other, that is to say AB equals to EC. But it is given us that in the equation that AB equals to 6, therefore EC will be also equal to 6. Likewise, according to the same rule that the opposite sides of a rectangle are equal to each other, in rectangle BAEC we will get that BC equals to AE. But it is given us in the equation that BC equals to 13, therefore AE must be also equal to 13. Here AE must be also equal to 13 units. And what is the length of line segment ED? From the drawing it is very easy to see that the length of this line segment ED is equal to AD minus AE. AD is 18, AE is 13, so AD minus 18, AD minus AE is 18 minus 13, that is 5. So line segment ED equals to 5 units in its length. Then we joined points D and C together by a straight line. In this way we created the green small right triangle ECD. And then we implemented the Pythagoras theorem on the green small right triangle ECD. In the right triangle ECD, the right green triangle ECD, according to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. The hypotenuse is DC, therefore the square of the hypotenuse is this C square, and it must be equal to the sum of the squares of the perpendiculars, that is to say it must be equal to EC square plus ED square. So DC square must be equal to EC square. EC equals to 6, therefore EC square equals to 6 squared, that is 36. Plus ED square. ED equals to 5, therefore ED square equals to 5 squared, that is 25. So in conclusion, we found out that DC square equals to 36 plus 25. So 36 plus 25 is 61. So in conclusion, we found out that DC square equals to 61. We took a root out of this equation and we found out that DC equals to the square of 61 units. Here, the hypotenuse DC of the small right green triangle, DC equals to the square root of 61 units. Then we joined points B and D together by a straight line. By joining points B and D, we created the right triangle ABD. This right triangle ABD. Then we implemented the Pythagoras theorem on the right triangle ABD. Okay, according to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. The hypotenuse is BD, therefore the square of the hypotenuse is BD square, and it must be equal to the sum of the squares of the perpendiculars, that is to say it must be equal to AB square plus AD square. So BD square equals to AB square. AB equals to 6, therefore AB square equals to 36. Plus AD square, AD equals to 18 units, therefore AD square equals to 18 squared, that is 324. In conclusion, we found out that BD square equals to 36 plus 324. 36 plus 324 is 360. So we found out that the square of the hypotenuse BD equals to 360. We can substitute 360 by 36 times 10. We did it and we got that BD square equals to 36 times 10. Then we took a root out of this equation and found out that BD equals to the square root of 36 times 10. The square root of 36 is 6, therefore we can take out 36, we can take 36 out of the root. We did it and we got that BD equals to 6, and inside the root we left only with 10. So in conclusion, we found out that the length of the hypotenuse BD on the right triangle ABD equals to 6 times square root of 10 units. Here, the length of this hypotenuse BD equals to 6 times square root of 10 units. In the next step, we actually calculated the area of the green triangle DBC. This green triangle DBC. Okay. The area, the square bracket is the sign for the area. The area of the green triangle BDC equals to the base of the triangle times the height to the base over 2. I must emphasize that the height to the base must create 90 degrees with the base. Okay? So the area of triangle DBC, we choose the base of the green triangle BDC as BC, and we have to multiply it by the height over 2. Again, the height must create 90 degrees with the base BC or with the extended base BC. So, only if we extend BC by straight line, we can create 90 degrees with the extended BC. Otherwise, it is impossible to create here 90 degrees. So we extended BC by straight line, and from point D, we draw perpendicular on the extended BC. That is to say, this angle equals 90 degrees and this angle equals 90 degrees according to our construction. So you can see here that DF creates 90 degrees with the extended base BC. Therefore, DF is the height to the base. Okay? So, we have to find out the value of the height. Okay? So we focused on quadrilateral ABFD. This quadrilateral has 1, 2, 3 right angles. Therefore, the fourth angle must be also equal to 90 degrees. Therefore, quadrilateral ABDF has 4 right angles, and therefore quadrilateral ABDF is a left angle. Okay, I wrote it down that quadrilateral ABDF is a rectangle. But we know that the opposite sides of a rectangle are equal to each other. Okay, so here, rectangle ABDF, AB equals to DF. Okay, AB equals to DF, but it is given as the equation that AB equals to 6. We can write here that AB equals to 6, and from this equation 6 equals to AB equals to DF, we will derive that DF is also equals to 6 units. Yeah. DF is equal to 6 units. That is to say, the height to the base BC of the green triangle BDF, it is equal to 6 units. Now we can easily find out the area of the green triangle BDF. Okay, so the area of the green triangle BDF will be equal to the base that is BC, and we know that BC equals to 13 units in its length, times the height to the base, and we just right now found out that the height to the base is equal to 6 units, all divided by 2. In conclusion, we found out that the area of the green triangle BDF equals to 13 times 6 over 2. 6 over 2 is 3, and 3 times 13 is 39. In conclusion, we found out that the area of the green triangle BDF equals to 39 square units. Okay, in the next step, I presented to you a new rule and implemented the new rule in our drawing. According to the new rule, that is actually rule number 1, if triangle ABC if a triangle is blocked by a circle, here we have triangle ABC that is blocked by this circle. So any triangle that is blocked by circle, we can find out the radius of the circle that blocks the triangle by using this formula. Then the radius of the triangle that is blocks the circle, that is to say the radius of this circle, will be equal to, here the length of side AB is A units, the length of side AC is B units, and the length of side BC is C units. So the radius of the triangle, this triangle that blocks the circle, the radius of the circle, this circle that blocks triangle ABC, will be equal to A times B times C. That is to say, the multiplication of the side lengths of the triangle by each other over 4 times the area of this triangle, triangle ABC, that is blocked by the circle. Okay, again, whenever you have a triangle that is blocked by a circle, then the radius of the circle that blocks the triangle will be equal to A times B times C. That is the multiplication of the side lengths of the triangle by each other over 4 times the area of the triangle that is blocked by the circle. So we actually can implement rule number 2 in our drawing. Why? Because in our drawing we have the green triangle, triangle BDC. You can see here that this vertex touches the circle at point B, this vertex touches the circle at point C, and this vertex touches the circle at point D. Therefore, we can say obviously that the green triangle BDC is blocked by the circle. Why? Because all of its 3 vertices are touching the circle at different points. And because of the fact that the green triangle is blocked by the circle, we can implement here rule number 1. Okay, so I wrote it down actually. The green triangle, triangle BDC, is blocked by this circle, and therefore we can implement here rule number 1. That is to say, the radius of this circle, that is equal to capital R according to our definition, will be equal, according to rule number 1, to the multiplication of the side lengths of the triangle, the green triangle BDC. That is to say, BC times CD times BD, BC times DC times BD, over 4 times the area of this triangle, triangle BDC. So R equals to the length of BC is 13 units, the length of CD is the square root of 61 units, and finally the length of side BD of the green triangle and BDC is equal to 6 times square root of 10. Okay, and all divided by 4 times the area of the green triangle BDC, and we have already found out that the area of triangle BDC equals to 39 square units. Okay, so actually that is the answer to the question, that the radius of this circle equals to this expression. Here we simplified the expression by dividing both the numerator and the denominator by 13. So here in the numerator we have 13 over 13 is 1, so 13 will get cancelled. We are left only with the square root of 61 times square root of 10 times 6 over 4 times 39. 39 over 13 is 3. So in conclusion, in the denominator we left only with 4 times 3. And 4 times 3 is 12. So in the denominator we left only with 12. In the numerator we have square root of 61 times square root of 10 times 6. Here we divided both the numerator and the denominator by 6. So in the denominator we have 6, therefore 6 over 6 is 1, so 6 will get cancelled, and we left only in the numerator with square root of 61 times square root of 10. In the denominator we have 12, and 12 over 6 is 2. So in conclusion, we found out that the radius of the circle, the radius that we are looking for, equals to the square root of 61 times square root of 10 over 2. According to the algebraic identity that the square root of A times square root of B equals to the square root of A times B, we will get that the square root of 61 times square root of 10 will be equal to the square root of 61 times 10, all divided by 2. And 61 times 10 is 610, of course. Therefore, we found out actually that the radius of this circle, that is to say capital R or OM, it is equal to either the square root of 610 over 2 units, or in terms of numbers, it is equal to 12.349 units. So we finished with the first method. In the next step, I actually presented to you the second method. So I repeat on the second method. In the first step, we did all the things that we have already done in the first method, that is to say, from point C we draw perpendicular on AD, that is to say this angle equals to 90 degrees and this angle equals to 90 degrees according to our construction. We define the touching point of the perpendicular from point C and AD as E. Okay? Then, actually, here we created quadrilateral ABCE. In quadrilateral ABC we have 1, 2, 3 right angles, therefore the fourth angle must be also equal to 90 degrees, therefore quadrilateral ABC is a rectangle, we know that the opposite sides of rectangle are equal to each other, that is to say AB equals to EC, but AB equals to 6, therefore EC also equals to 6. Likewise, according to the same rule that the opposite sides of rectangle are equal to each other, we get that BC equals to AE, but it is given us the equation that BC equals to 13 units, therefore AE will be also equal to 13 units. Then we found out the length of DE or ED equals to AD minus AE, that is to say ED equals to AD that is 18 minus AE that is 13. 18 minus 13 is 5, so ED equals to 5 units. From this step we continue with the second method, that is to say from point O we draw perpendicular on chord BC, that is to say this angle equals to 90 degrees and this angle equals to 90 degrees according to our construction. Then we define the touching point of the perpendicular from point O, that is the center of the circle, to BC as capital M, and we define the touching point of the perpendicular from point O and AE as capital M. Then I presented to you rule number 2, and we implemented rule number 2 in our drawing. According to rule number 2, the perpendicular from the center of the circle, that is to say from point O, to chord BC, that could be any chord, or the perpendicular from point O to any chord, bisect the chord. Here we have perpendicular OM towards chord BC, therefore it bisects chord BC. That is to say BM equals to MC. Okay? Again, chord BC could be any chord. So we can implement rule number 2 in our drawing. Why? Because in our drawing we have the perpendicular ON towards chord BC, and according to rule number 2, it bisects chord BC. That is to say BN equals to NC. Okay? I repeat again. In our original drawing, we have the perpendicular ON, this perpendicular ON towards chord BC. From the center of the circle to chord BC, and therefore, according to rule number 2, the perpendicular ON bisects chord BC. That is to say BN equals to NC. Here BN equals to NC according to rule number 2. Then we actually focused on quadrilateral ABMN. In quadrilateral ABMN, we have 1, 2, 3 right angles. 1, 2, 3 right angles. Here, this is the fourth angle, because we have perpendicular ON, therefore this angle equals 90 degrees. So we have 3 right angles inside quadrilateral ABMN. Therefore the fourth angle, this angle must be also equal to 90 degrees. Therefore inside quadrilateral ABMN we have 4 right angles, therefore quadrilateral ABMN is a rectangle. We know that the opposite sides of a rectangle are equal to each other, that is to say AM equals to BN. Here I repeat again that quadrilateral AB and N is a rectangle, and the opposite sides of a rectangle are equal to each other. That is to say, AM equals to BN. Likewise, in quadrilateral MNEC, we have 1, 2, 3 rectangles. Therefore, the fourth angle must be also equal to 90 degrees, and therefore quadrilateral MNEC is a rectangle. Here, quadrilateral MNEC is a rectangle. In the rectangle, we know that the opposite sides of a rectangle are equal to each other. That is to say, ME equals to NC. ME equals to NC. So we can summarize what we did until now. According to rule number 2, we found out that BN equals to NC. But BN equals to NC, but BN it is also equals to AM. According to this formula, so we can write here that BN equals to AM. And we also found out that NC it is also equals to EM. Therefore, we can write here that NC equals to EM or ME or EM, it is the same. So from this long equation, AM equals to BN equals to NC equals to ME, we will derive that AM equals to ME. AM equals to ME. Okay. Then actually, so here AM equals to ME. Then we extended line segment AD or DA until it touches the circle at point F. And here we have perpendicular ON. This is perpendicular to chord BC. So any perpendicular must be a straight line. So ON is a straight line. So if you focus on the upper side of the straight line ON at point M, here the sum of the angles must be equal to 180 degrees according to rule number 1. Therefore, this angle is equal to 90 degrees plus the missing angle. In total, they must be equal to 180 degrees. Therefore, the missing angle must be also equal to 90 degrees. Likewise, if we focus on the lower side of the straight line ON at point M, here the sum of the angles must be equal to 180 degrees according to rule number 1. This angle equals to 90 degrees plus the missing angle. In total, they must be equal to 180 degrees. So the missing angle here must be equal to 90 degrees. So we actually found out that OM is perpendicular to chord FD. Why? Because this angle equals to 90 degrees and this angle equals to 90 degrees. Whenever you have from the center of the circle perpendicular to any chord, according to rule number 4, the perpendicular bisects the chord. That is to say, the perpendicular OM bisects chord FD. That is to say, FM equals to MD. According to rule number 2, FM equals to MD. I repeat again. OM is perpendicular to chord FD. As you can see, OM is perpendicular to chord FD. Why? Because this angle equals to 90 degrees and this angle equals to 90 degrees. Therefore, according to rule number 2, it bisects the chord FD. That is to say, FM equals to MD. FM equals to MD according to rule number 2. But what is the value of FM? FM equals to FA plus AM. FM equals to FA plus AM. And what is it is equal to MD? What is the value of MD? MD equals to ME plus ED. And here MD equals to ME plus ED. Okay? So we actually found out that FA plus AM equals to ME plus ED. But we have already found out that AM equals to ME. AM equals to ME. So here AM equals to ME, therefore we can cancel those two line segments because they are equal to each other. Okay, and we're left only with FA equals to ED. In this equation we're left only with FA that is equal to ED. Here FA equals to line segment ED. But we have already found out that ED equals to 5 units. So we can write here that ED equals to 5. And from this equation FA equals to ED equals to 5, we will derive that FA is also equals to 5 units. Here FA equals to 5 units. In the next step we extended side BA until it touches the circle at point P. So actually defined the touching point of the extended side BA and the circle as point P. Then I presented to you the old rule number 2, and we implemented the old rule number 2 in our drawing. According to the old rule, that is rule number 2, if chord AB intersects with chord CD at point O, then AO times OB equals to CO times OD. Again, AO times OB equals to CO times OD. Okay, we can actually implement rule number 2 in our drawing. Why? Because in our drawing we have chord FD that intersects with chord PB at point A. Again, chord FD intersects with chord PB at point A. Therefore, we can implement here rule number 2. I repeat again. In our drawing, we have chord FD that intersects with chord PB at point A. Therefore, according to rule number 2, we'll get that FA times AD equals to BA times AP. Again, FA times AD equals to BA times AP. Again, FA times AD equals to BA times AP. Okay? We have already found out that FA equals to 5 units, AD equals to 18 units, and AB equals to 6 units. So we found out that 5 times 18 equals to P8 times 6. We divided this expression by 6, and we found out that P8, the missing line segment, equals to 5 times 18 over 6. 18 over 6 is 3, and 3 times 5 is 15. In conclusion, we found out that the length of this line segment P8 is equal to 15 units. Then I presented to you rule number 4, and we implemented rule number 4 in our drawing. According to rule number 4, it is true in any circle. Whenever, according to rule number 4, whenever we have two chords that are perpendicular to each other, we can implement here rule number 4. And the following equation is true. So here we have chord AB that intersects with chord CD at 90 degrees. In other words, chord AB is perpendicular to chord CD. Therefore, we can implement here rule number 4. And according to rule number 4, here R is the radius of this circle. EM equals to capital R, that is the radius of this circle. So 4R squared equals to AO squared plus OB squared plus CO squared plus OD squared. Again, if we know that two chords are perpendicular to each other, we can implement here rule number 4. According to rule number 4, 4R squared, and R is the radius of the circle, equals to AO squared plus OB squared plus CO squared plus OD squared. Okay? We can actually implement here rule number 4. Why? Because in our drawing, we have chord FD is perpendicular to chord PB. Again, chord FD is perpendicular to chord PB. Why? Because they create an intersection point 90 degrees. This angle equals 90 degrees. That is to say they are perpendicular to each other, therefore we can implement the rule number 4. So I repeat again. Chord FD is perpendicular to chord PP at point A. Chord FD is perpendicular to chord PB at point A. Therefore, according to rule number 4, we get that 4 times R squared, and R is the radius of this circle, will be equal to FA squared plus AD squared plus PB plus PA squared plus AB squared. Again, 4R squared, R is the radius of the circle, equals to FA squared plus AD squared plus PA squared plus AB squared. I repeat again, according to rule number 4, because we have in our original drawing two chords that are perpendicular to each other, we get that 4R squared, when R is the radius of this circle, it is equal to PA squared plus AD squared. And PA squared plus AD squared, again, it is actually FA squared. It is actually FA squared. No. Okay. It is FA squared plus AD squared plus PA squared plus AB squared. Okay, so 4R squared equals to FA squared. FA equals to 5, so FA squared equals to 5 squared, that is 25. plus AD squared. AD equals to 18, therefore AD squared is 18 units, that is 324. Plus PA squared. PA equals to 15, so PA squared is 15 squared, that is 225. Plus AB squared. AB is 6, therefore AB squared is 6 squared, that is 36. In conclusion, we found out that 4R squared equals to 25 plus 324 plus 225 plus 36. Here, 25 plus 225 is 250, and 324 plus 324 plus 36 is 360. So we got that 4R squared equals to 250 plus 360. 250 plus 360 is 610. In conclusion, we found out that 4 times capital R squared equals to 610. So R squared equals, we divided this equation by 4, and we found out that R squared, or capital R squared, equals to 610 over 4. We took a root out of this equation, and we found out that capital R squared equals to the square root of 610 over 4. That is to say, the radius of this circle, the radius that we are looking for, the radius of this circle, OM, equals to the square root of 610 over 4. That is to say, it is equal to the square root of 610, and the square root of 4 is 2. So you can take out 4, they can take 4 out of the root, and we left only the radius of the circle. It is equal to the square root of 610 over 2 units. So in terms of numbers, it is equal to 12.349 units. Okay, thank you very much.